Okay, hello there, y'all. Welcome back. This is our first test review for this year so far. New year. Okay, we'll go ahead and get started here. This is for Unit 6 for our test. It's going to be on the 16th. Again, just like make sure you can do this, and then you can do the test. It'll be very easy. Okay, Taylor wanted to find the height of a statue of a pineapple in Nambour, Australia. She measured the pineapple shadow at 8 feet 9 inches and her own shadow at 2 feet. Taylor's height is 5 foot 6 inches. What is the height of the pineapple in feet? Okay, so first thing we need to set up proportions, and I'm going to do height to shadow on each of these, okay? And so one's going to be for the statue and one is going to be for Taylor. And of course, since we have 8 feet 9 inches, we need to turn this to a decimal. Okay, so it makes it easier to work with. So pineapple, the pineapple shadow is 8 feet 9 inches, so that's 8.75. And we need to find the height of the pineapple in feet, so that's our question mark. Okay, Taylor's height is 5 feet 6 inches, so that's 5.5 feet, and her shadow is 2 feet. Okay, so here we go to our cross products. So we have 5.5 times 8.75, so that's 48.125, and that's equal to 2, we'll call it x, okay? So divide by 2. So we get 24.0625. Okay, 24.0625. So this first part, that's our number of whole feet. So it's 24 feet. And then to get what this is in inches, you do 0.0625 times 12. Because we're trying to find basically what 6.25% of 12 is. So 0.0625 times 12, and it's 0.75 of an inch. So it's 0.75 inches. So 24 feet and 3/4 of an inch. I know, a little bit weird, but hey. Okay. A student who is 60 inches tall measured shadows to find the height of a tree. The student's shadow was 24 inches long. So again, we'll do height to shadow. So 60 inches to 24 inches. Okay. So these are in inches. And then it says the shadow of the tree was 13 feet long. So 13 feet, we have to multiply that by 12 to get it in inches. So 13 times 12 is 156. 156. And so we have height on top, shadow on bottom. Okay, so the 60 and the 24 deal with the student, and then the tree over here, it says the shadow was 13 feet long. So shadow goes on the bottom, so 156 goes on the bottom. And we're trying to find the height. Now, all of this that we're dealing with is all in inches, okay? So you could easily convert the height and the shadow of the student to feet and do it that way, or we can do like we're doing here and just convert at the end. But again, don't worry, on the test you're not going to have with all this conversion stuff, okay? So 60 times 156, ooh, that's a fun number. It's 9,360, and then that's equal to 24x. Okay, so divide by 24. So x is 390. Now this is 390 inches. So to get it in feet, just take this and divide it by 12. So it's 32.5 feet. There we go. Okay, question 3. It says Marvin is building a 2-story jungle gym according to the plans below. What would be the value of x? Okay, so we have here, it's like 2 triangles going on, okay? So what we need to do, okay, is actually introduce another variable right here, okay? Because what we're going to do is we're going to look at the big triangle. I'm going to find this piece of the small triangle, and then I'm going to use that to find x. Okay, so we have the small triangle. Its height is 8 feet, and we don't know this part. Then we have the bigger triangle. Okay, the height of it is this 8 plus the 10, so that's 18. And then the whole height of it, the whole hypotenuse is 24. Okay, so we're just going to use this here. So we have 8 over 18 is equal to y over 24. So just cross multiply and divide here. So 18y, 24 times 8 is 192. So it's 10.6 repeating, okay? So that's 10 and 2/3, okay? And so then we'll just subtract. So we'll do 24 minus 10 and 2/3. So 24 minus 10 plus 2/3. Okay, and it's 13.3 repeating, aka 13 and 1/3. Okay, number 4, I'm sorry. Use the given information to find each measure. BE is parallel to CD. Okay, good. Look at that. That makes our life so much easier. We need to find CD, AC, and BC. All right. So CD, BC, and AC. Okay, first start off with the easy part, BC. Okay, remember when these are parallel, the pieces are proportional. So you have 12 to 6 is equal to 15 to question mark. Okay, 12 to 6, well, that's 1/2, because, it reduces to 2. All right, so basically, if you take 12 and you divide it by 6, you get 2. So 15 divided by what gives you 2? Well, it'd be 7.5. But you can still do these cross products. 15 times 6 is 90. Okay, and then divide that by 12, and you get 7.5. So BC is 7.5. Okay, so then AC, well, you just take the two pieces and you add them. So 7.5 plus 15 is 22.5. Okay, now we can use the fact that we know the whole thing to find these bottom pieces, because we have to use the two smaller triangles. So we have, and then this part here, that's 18. Okay, but you don't really have to know that side. So anyway, 15 to 22.5 would be equal to 8 over CD. That's our question mark. So just multiply here. So we get 180 is equal to 15 times we don't know, divide by 15, and so you get that this guy is 12. So CD is 12. All right, very good. Okay, number 5, it says solve for x. So your cross products here. Okay, 16 times 4, that's 64. And we have x minus 5, we have to multiply that by itself. So x minus 5 times x minus 5. X times x, that's x squared minus 5x. Okay. And then we have, again, another minus 5x. And then we have a negative 5 times a negative 5, so that's a positive 25. So we have x squared minus 10x plus 25 equals 64. Okay. We need to get this set equal to 0. So take away 64. 25 minus 64 is negative 39. So you have x squared minus 10x minus 39 equals 0. Okay, So this is the part where we have to find two numbers that multiply to negative 39, but then when we add them, we get negative 10. Okay, 39, its factors are either 1 and 39 or 3 and 13. Obviously, we have to go with the 3 and the 13. Okay, and so we have to have the negative 13 and a positive 3. Okay, so x minus 13, x plus 3. Because when you do negative 13 times positive 3, you'll get negative 39. But then when you add them, you'll get that negative 10. So x is either 13 or negative 3. All right, solve for x. Okay, we got parallel lines here, so we know our pieces are proportional. So 18 over 6 is equal to x plus 22 over x plus 2. Okay, when you cross multiply, you'll just have to distribute. So I'm just going to do that all in one step. So we have 6x plus, and then 22 times 6 is 132. Okay, and then we'll do the other way. 18 times x is 18x, and 18 times 2 is 36. Okay, so take away 6x. Take away 6x. Take away 36 as well. Okay, so 132 minus 36, that's 96. 18x minus 6x is 12x. So x is 8. Alright, question 7. Solve for x. Okay. We don't know if these are parallel. Okay. And we also don't have the other side parts here, so we can't use that proportionality thing. So we have to look at these as two triangles. So we have the 12 and the 8. And we have 12 for that side there, and this is 12 plus x. Okay, so 8 to 12, I'm doing these guys together, okay, would be equal to 12 over 12 plus x. Okay, cross multiply. So 144, because 12 times 12, and then I'm going to cross multiply here. So 8 times 12 is 96, plus 8x. So 144 minus 96, that's going to be 48 is equal to 8x. Divide by 8, so x is 6. Okay, on this one we have to solve for both x and y. Okay, so the 4 and the 6, those match. 12 and the 18, those match. And then the y and 12, and then your x and your 9. Okay, easy thing to do here. So we have y over 12 is equal to 4 over 6. So cross multiply. So 6y is equal to 48. So y is equal to 8. Okay, and then we have x over 9. We can use the same one, 4 to 6. So 6x is 36. So x is 6. Okay, next couple questions here. It says, given that triangle PQR is similar to triangle STV, find ST. Okay, PQR is right here. So we have 30, this top part here, and that's comparing to ST. Okay, so this is our question mark. And then now we have to use the bottom sides. If you look carefully here, okay, from Q to R, it's the 17 and the 19 together. So you have to add them. So you have to do 17 plus 19, which is 36. So you have 36, and then now for the smaller triangle, we have the 19 plus the 5. So 19 plus 5 is 24. So I have big triangle, small triangle, big triangle, small triangle. So do our cross products. So 36 times question mark. So 24 times 30 is 720. Okay, divide by 36. And we get 20. So ST is 20. Okay, two triangles are similar. If their ratio of similitude is 8 to 3, find the missing side. Okay, 8 to 3. And we need to find x. So we have 8 over 3 is going to be equal to x to 18. So just do your cross products. So 3x is equal to 144. Okay, and divide that by 3. So x is 48. All right, our next section, geometric mean. Okay, and on these you'll have to be careful on the test and stuff. Just make sure, like, if it's asking you to round to the nearest 10th or to the nearest 100th, make sure you do that. Otherwise, you have to put it in simplest radical form. Okay, so on this one we have to find both x and y, and the hint is to find y first. Okay, so y is part of this hypotenuse here, but we don't know the altitude and we don't know the other piece of the hypotenuse. So we're going to have to do boomerang because we know the 6 or we know this 8. Okay, but again, we can't use the 8 because we don't know FG, so we have to use the 6. So remember, you have the 6, and boomerang goes all the way around and comes back. Okay, so we have your leg pieces go on the diagonals. Okay, and then your hypotenuse pieces go on the other diagonal. So we have y, and we have the 10. And y'all, it doesn't really matter which diagonal you put which, as long as the things that need to be diagonal from each other are, then you're good. So 10y is equal to 36, so y is 3.6. Okay, so y is 3.6. And then now we can find x. So in order to find x, we have to do the heartbeat method. So first we have to subtract. So 10 minus 3.6, it's 6.4, I believe. Yes. So this piece right here is 6.4. Now we can do the heartbeat. So we have x on the diagonals, and we have the first part, y is 3.6, and the other part is 6.4. Okay, so x squared times 3.6. All right, and you get this lovely number, 23.04. Keep all those digits. If you don't keep them all, your answer's not going to come out nice. So now, just take the square root of that, square root of 23.04, and you get 4.8. So x is 4.8. All right. Question 12, find x. Okay, we're going to have to do boomerang method on here, but first we've got to do a little subtraction. So do 32 minus 24, which gives you 8. Okay. So you have the leg pieces, which is x there. Okay, the part closest to it over the whole thing over there. So you have x squared equals, okay, 256. Take the square root. And so you get x is 16. Because 256 is a nice, good square root. Alright, find the value of each variable. So we have x, y, and z. Okay, fun times here. Let's do the first one. We'll do y. Okay, we got y's on the diagonals there. Then we have one piece of it, 6. The other piece of it, 24. So y squared, 6 times 24 So 144. Okay, so the square root of that y is 12. Okay, so there's y. Okay, now x and z. Let's do x first. So we have our x's here. We have 6, and then 6 plus 24 is 30. So x squared is 180. Okay, and then 180 is not a perfect square, so we're going to have to simplify this. So x, 180 breaks down to 18 and 10. 10 is 5 and 2. 18 is 9 and 2. 9 is 3 and 3. Okay, so it looks like we have a pair of 2's and a pair of 3's. So we have 2 times 3, and then the 5 stays inside. So it's 6 square roots of 5 for x. Okay, and then now we will find z. So we have z on the diagonals. Okay, and we have the part closest, 24, over the whole thing, which is 30. So 24 times 30. So z squared is 720. Okay, and 720 is not a perfect square root. So start breaking it down. We got 72 and 10. Okay, so 10 breaks down to 5 and 2. 72 is 9 and 8. Okay, so 8 breaks down to 4 and 2. And the 4 breaks down to 2 and 2. 9 is 3 and 3. Okay, so we have a pair of 3's, so we're going to bring, so z equals, okay, we have 3 outside. I have 2 pairs of 2's, so I'm going to do 2 2's. And then I have a 5 left, so that stays in. So z equals, so you 3 times 2 is 6, times 2 again, so it's 12. So it's 12 square roots of 5. That was fun. Alright, now it says find AC. It tells us BD is 8 and that AD is 4. Okay. Basically, we need to find DC here. Okay, and then we could find what AC is. Okay, we're going to have to use the heartbeat method here, but it's going to be a little bit differently. So remember, your altitude goes on one diagonal, so we're going to have 8 and 8 here. One piece of the hypotenuse goes there, and the other part goes right here. So you just do our cross products. So 64 is equal to 4 times some number. So basically, you just take 64 and divide it by 4, and you get 16 here. And so now AC, you gotta do 4 plus the 16, so it is 20. Okay, next is our last section here. Almost there. It says proving similar triangles or proving figures similar. Determine whether the following triangles figures are similar for the triangles. If yes, by what theorem? And then provide a similarity statement. If they're not similar, then you state not similar. Alright, here we go. This first one, we are given angles and no sides. So our only option would be angle, angle. Okay, and we have 2 that are corresponding. Okay, so these are similar by angle, angle. And now we just have to follow the naming. So TAB is going to match up with TME. Okay, 16. Are these two similar? Yes or no? If yes, how? Alright, small side is 12, matches with the small side 4 here. 15 is bigger, matches with the 5, which is bigger. We have this angle in the middle. So this is a candidate for side angle side. So 12 to 4, that equals to 3. 15 over 5, that equals to 3. So those are good. So yes, they're similar. and it's by side, angle, side. And just check these names here as well. BCE, DAE, yep, those were good. Alright, 17. Which of the following triangles can be proven similar with the given information? List any and all that apply. And you can solve for the missing angles if needed. Okay. So 1 and 2, we can't really, solve for any angles because we only have one, and we're not told if they're isosceles or anything like that. So 1 and 2, we can't really prove those similar to each other, okay? Because we just don't have enough information, all right? Because you can't do side angle side because you don't have this corresponding angle on both of them. I know we can see like the 2 and, like 2 times 2 and 4 times 2. Those give us the 4 and the 8, but we don't know this other side here. So we can't do angle angle, we can't do side angle side, we can't do side side side. So we can't prove 1 and 2 similar. So let's see, can we prove 1 and 3 or 2 and 3? Okay, those are our options. So 1 and 3. Okay. Triangle 3, this is good because we can find that missing angle. So 50 and 30 is 80. 180 minus 80, this is 100. Okay, good. Look at that. 1 and 3, we got that matching angle. So we could see, can we do, we can only do like side angle side on this because we don't have this third side here. Okay, so the hundreds, the angles match. Good. Now let's see about these ratios. 12 to 9 should be equal to 8 to 6. Okay, look at your cross products. Do 12 times 6 and 9 times 8. 12 times 6, 72. 9 times 8, 72. Are their cross products the same? Yes. So 1 and 3 can be shown to be similar. All right, now let's look at 2 and 3. Okay, 2 and 3, well, you would think maybe we could do like side angle side or angle angle, something like that. But again, we only have the one angle and we don't have the proper sides to be able to match it up. So in this case, only 1 and 3 can be proven similar. 18. Name the pairs of corresponding sides of the two figures. Knits is similar to purls. Find the length of side NI. Okay, so when you do this, just match out the name. Okay, so S is in between. So KN and PU, those match. So circle, circle. Okay. TS matches with LS, but we don't have information there, so we don't really need that. We need to find NI, okay, and that's going to match with UR, okay, so I'm going to put a box. All right, now I've got enough, and this says name the pairs of corresponding sides. So KN corresponds with PU, okay, NI corresponds with UR, IT corresponds with RL, and TS corresponds with LS. And you can't forget the last ones. SK corresponds with SP. Right, so those are those. Now we'll just set up a simple proportion to find our missing side. So question mark over 16 is equal to 30 over 10. So do your cross products. So 10 question mark. So 16 times 30. That's 480. Divided by 10. So you get that this side here, NI, is 48. All right, there we go. Next, two last ones. Would the following triangles be similar or not? And this is just based on what's given to us. Okay, first ones. We are only given angles, so we need to look at those angles here. So 180 minus 90. Okay, so that's 90. Now take away 35. So this one is going to be 55. All right, and then the other one, we still have the 90, so 90 minus 45 That's 45. So can these be similar? No. Okay, how about these guys? Could these ones be proven similar by angle, angle? Well, we're not given really any markings here, but we're told, or I'm sorry, any numbers, but we're told that you see these angles here, these isosceles, the base angles, they're different measures. So they don't have two angles similar to each other, so no. All right, last part here. What kind of triangles are these? They have 3 equal angles. Well, they're equilateral. Okay, equilateral triangles, they're going to be 60 degrees, all their angles. They're going to be 60 degrees no matter what. So they're always going to be similar. Okay, so if you look at it, right triangles, are they going to always be similar? No, they have a right angle, but their other 2 angles could be different. Same thing with isosceles. You know, these top 2 angles, they could be the same, but you see those base angles there? Okay, well, actually, the top angles couldn't be the same. But like the base angles, you see how the base angles are different? If those are different, well, then you can't have similar triangles. But equilateral triangles, all 3 angles, they're always going to be 60, so those are always going to be similar. They might not be congruent, but they'll always be similar. Okay, 20. As the triangles are marked, which theorem can be used to prove them similar? If not, what extra information can be given to prove them similar? Okay, so let's, kind of look and see here. Z belongs with both of them. Okay, Z belongs with both of them. And we can also see here that they both have an 87-degree angle. So angle D and A have to match up, and Z has to match with Z. Okay, and then that would mean that K would have to match with M. So could we prove these similar? Well, yeah, think about it. Angle D and angle A, they're both 87. And do you see how they both share angle Z? Well, that means it has to be the same measure, okay, on both of them. So, by default, can we prove these similar? Yes, and it would be angle, angle. Yes, by angle, angle. And it's because of that Z that they share and the fact that they tell us that these are both 87 degrees here. Okay, so that's it for our review for this test. I know it was a little bit long, but hopefully we got the idea down and you should be successful in the test. See you then.